Good evening. Thank you, all of you, for being here, and thank you to TEDx for giving me this opportunity to talk about my passion. I'm going to tell you today how the Veena sings. This instrument I'm holding is known as the Saraswati Veena. It is a traditional instrument of the south of India. There are several kinds of Veenas. There is Rudra Veena, Vichitra Veena, and the Saraswati Veena comes from the south of India. There are several kinds of Saraswati Veena too. The one I'm holding here is from Thanjavur, the Thanjavur Saraswati Veena. And the Veena has defined and refined the classical music of the south of India from historic times. And the instrument, as I said, is placed in the hands of the goddess Saraswati, who is the deification of knowledge and the arts. And the science of this music is attributed to a celestial sage, Narada. Now, the vibrations of this rather majestic instrument resonate with one's body and mind, the way in which we hold the instrument, and how this part of the body, the resonator, which is called the kudam, is like the human thorax from where the sound emanates. The strings are like the vocal cords, and the life breath kind of vibrates this instrument. And it resonates to one's body and one's mind, to one's nerves and one's moods, everything. Vasanta, the mood of spring, bright and hopeful. So today I try to talk about how the Veena produces this sound which is so unique to this instrument, which is different from, just having a string tied between 2 points. Saraswati is still looking benignly down at us. So what I want to show you today is that while the resonator supports specific frequencies, that what's called the tone or the pitch of the instrument is related to the frequency of the string, and the resonator supports specific pitches, and that's called, and the pitch that is maximum resonating to the kodam is called the sa, or the tonic, the sound of the open string. We tune 4 other strings on which the playing is done to the tonic, to the 5th note, which is also called pa, and then 1 octave lower, that's also sa, and then the 5th, which is another octave lower, out of tune. Pa, sa, pa, sa. So we can cover 2.5 octaves of notes on the fingerboard. Sa, pa, sa. So they chime in tune, chime with the rhythm that beats with the music. Now the basic physics of the Veena is that of a stretched string, right? And the pitch depends on the length of the string. And we find that depending on how the string is tuned, so there are 3 graphs, the string is tuned to a lower frequency, slightly higher frequency, and a really high frequency. So in these 3 different tunings, 3 different tightenings of the string, we see that each bar there stands for 1 frequency, 1 multiple of F. And there are so many bars. I don't see a single bar. This is not a single sound. This is a whole gamut of sounds. There's a whole spectrum of sounds in a single string. And the height of each of those bars represents the strength of each of these frequencies. And the middle graph that you see there has pretty tall spikes. So it shows that all of those frequencies are represented in this sound. If you tighten the string, the sound changes a little bit. The composition in terms of number of frequencies changes. Now, the other thing that we see is that by the very fact that the Veena supports so many frequencies, music just arises out of the tone of the instrument itself. Okay? And if you look at the ratios of the frequencies, then you will see that they are all integer ratios, and that produces very musical sound to the ear. So my colleagues and I got a project from the Department of Science and Technology to study the reason for the existence of all these frequencies in the veena. So we looked at the structure of the veena. Of course, the body resonates and so on. But why does a simple plucked string produce all these frequencies? The other important thing about the veena is this part of the veena, which is called the bridge, on which the string is supported. It's not a single point. It's a broad and curved metallic surface. So if you look at the string, it kind of touches this broad surface at many points. It's not a single point. And as the string vibrates, goes up and down, it touches this bridge at different points. That means the length of the string appears to vary as the string vibrates. And yet, the number of the frequencies that we see are not all kinds of continuous frequencies, but very discrete harmonics alone. So we did a lot of mathematical modeling and experimental simulations as well. And what we found is that this particular warm tone of this instrument is because of the shape of the bridge. It's crucial to the shape of the bridge. And what happens is, as the string vibrates, it touches the bridge, it interacts with the bridge, and energy is exchanged in such a way that not only is a whole range of harmonics produced, but also in the course of vibration. So this is a graph which sort of shows the energy in the string as time goes on. So as I pluck, slowly the energy or the loudness goes down, but it doesn't just go down smoothly, it goes up and down. That means in between the energy rises and then it falls and it rises and it falls. How does that even happen? That gives you this typical ringing sound of the veena string. It's not just a flat whistle note, but there's a roundness to the note, the ringing. So this happens because of the shape of the bridge. And we also performed experiments. I don't know if that picture is here, which showed that we took this bridge off and kept it on a simple, flat region. So that's as to isolate it from the podam. How does the bridge behave? And as we change the slope of the bridge, as we change the curvature of the bridge, we find that the spectral content of the veena changes, the sound changes. The beauty of the sound is intricately related to the precise slope and curvature of the bridge. And that precise slope is gotten by the artisans of Thanjavur and Bobili and Mysore, these hard-working woodworkers who sit in their little huts. It's obtained by just listening to the sound and optimizing the location of this bridge. Okay? So the physics that we are discovering now in the bridge was kind of felt in the fingers of the artisans who could somehow figure out the exact way in which the bridge is placed. Black because of the charcoal powder which is mixed in it. And then there is the resin of the sal tree which is also mixed to give it this particular texture. It's also very aromatic. And the locations of the frets can be slightly adjusted on this. Right now the fretboard is set and it is hard, so the frets are not moving. But over time, the wax tends to flow and the veena tends to go out of tune. So what do I do when my veena is out of tune? In Goa, we don't have veena makers, and the veena makers in Thanjavur are a fast dying breed. So I decided to do it myself. I was of course inspired by my father, who used to tune my mother's veena by taking a soldering iron and heating the metal a little bit and pushing the frets to the right location. So what I did was place the veena in the sun, wax melted, took up the wax, kneaded it, put it in a kadhai, stirred it, added more wax, added more charcoal, added more resin, and then took it out, and as the wax cools, you knead it to a smooth consistency, and then literally you sculpt the fingerboard out of it. So the fingerboard is first just placed on top of the wooden rails over here without the strings. Then the string is tuned. There are no frets, of course. Each of these is a small cylindrical piece of bell metal, which is a alloy of brass. And then we start tuning. How do we tune? I can position the frets based on the harmonics that the veena generates. Okay? So I tune the first string, and then it says sa to me. And I know that double the frequency is also sa, and it's a harmonic, and it will be excited. This is also the same sa, but twice the frequency. So at this position, how do I excite it without the frets? I place a finger slightly here. Do you hear it? I don't know. So I hear the higher harmonic and I put the sa here. Then 3 times the frequency is pa. I learnt my music from my mother, who imbibed it from a gentleman named Rangaramanuja Iyengar, who learnt it from a late 19th century veena artist called Veena Dhanammal. I mention her name here. She was at that time revered as Saraswati because her music was so unique. The fingering techniques that she brought out to evoke music out of the frets of the veena was very specific to her school. So it's called the Veena Dhanammal Bani. And I have not seen this technique exhibited by any other performing artist. So this is some kind of a treasure that I have, imbibed from this tradition. And the fact that there is this scalloping in the fingerboards kind of allows me freedom to pull the strings, to jump and dance on it and produce different sounds. Okay. So I'll choose to play the scale of Kannada. Scale of Kannada and the Raga Kannada. So I'll just play a small piece in praise of the celestial sage Narada, composed by Saint Tyagaraja Swami, set to Rupkatala. Spin, so it's gone out of tune today. Thank you.